let's explore the identity, constant, absolute value, and reciprocal functions. These are functions that are given by very fundamental formulas. The identity function. It's the function given by the formula x. So f of x equals x. A constant function. That's a function given by the formula c. C is a real number the absolute value function. That's the function given by the formula absolute value of x. And finally, the reciprocal function. That's the function given by the formula 1 over x. So we want to be familiar with the graphs and certain properties of these functions. For example, the domain, the range, the increasing, decreasing behavior of these functions. Let's go through some of these. What does the graph look like here? It's this line right here. And for a constant function, the graph will be a horizontal line. For example, if this is the point 0, c, then the graph of f will be the horizontal line through that point. The absolute value function has this as its graph. On this side, the graph looks just like the graph of the identity. And over here, we reflect about the x-axis and get a v. Remember, here's a definition of absolute value. And the reciprocal function. Its graph has two connected pieces, like that. So let's look at this absolute value function. Where is the function increasing? Where, if anywhere, is it increasing? And where, if anywhere, is it decreasing? Well, when we look left to right, we see that it starts out by decreasing. It decreases from negative infinity up to 0. And then it increases from 0 to infinity. Remember, we use open intervals to describe the increasing, decreasing behavior. Open intervals. How about the reciprocal function? What is the domain? Well, we can see that the domain from the formula, it's all real numbers except for exactly 0. So we omit 0. So there's the domain in interval notation. And in set builder notation, it's all the x's such that x is not equal to 0. And you can also see that from the graph, that the domain is everything except exactly x equals 0. And what about the range? Let's take a look at the graph. If we project the graph onto the y-axis, you see that all these points in the y-axis up here get hit. So the range will include all the y's greater than 0. And when we take the other connected piece of the graph, project that onto the y-axis, we see that all these points get hit. So all the negative values of y are outputs. 0 is the only one missing. So the range is all numbers except for exactly 0.